thank you very much for a very good presentation, and particularly for doing the context at the beginning. Yeah. I think it's very, very good. And now, to talk about maintenance planning and partner in progress, we have Rengarajan T, who is a maintenance planner for Kuwait petrochemical company. He has responsibility for maintenance planning for utilities and ethylene glycol plants. He graduated in mechanical engineering and started his career as a mechanical engineer some 23 years ago. Since then, he's had experience in projects, construction projects, commission, maintenance, reliability improvement, and energy conservation and petrochemical and power plants. Prior to being in Kuwait with Kuwait, he worked in planning, scheduling, debottlenecking and reliability projects with SABIC in Saudi Arabia and also in India. He's a certified project management professional. He's also a certified energy manager and energy auditor and boiler efficiency engineer, and certified maintenance and reliability professional. I also see that he's currently pursuing his Six Sigma Green Belt accreditation. This is something I expect we will see more of in this industry as time progresses. And I've seen it in other industries significantly over the last 25 to 30 years, but now it's the next mold where statistics have been used to as the sound basis for argument.
Maintenance planning, I think it is good for industries. This is the method to be used for. Okay. Please slide number. Okay, ladies and gentlemen, good afternoon. Just remember the sequence of events, what happened few seconds back. I have referred it to you little later during the course of the presentation. I am here to talk about the maintenance planning. Let us just have a look what we are going to cover today. We shall discuss about the paradigm shift about the maintenance, the point of view about from the industry's point of view, how they look at maintenance, what has changed in due course of time. Next, we will have a case study. We will talk a little about maintenance planning. We will talk about the characteristics and benefits of maintenance planning and what are the contributions maintenance planning can give to the industry, as well as the main important point of key performance indicators. How do you rate the maintenance planning? And we will have one more case study. Okay. See, the evolution of the industry can be distributed into three generations, to three parts. See, from 1930s, the industrialization started. From 1930s to 1950s was the first generation of industrialization. From 1950s to 1970s is the second phase of industrialization. Basically, as you all know that World War II happened from 1939 to 1945. After the end of World War II, there was a huge demand of products throughout the industry and there was a scarcity of manpower. So, the second generation of industrialization started in 1950. We will look into it a little shortly. And the third generation is after 1970s. As you can remember in the previous presentation, the presenter said that in 1970s the KNPC changed. In fact, from 1970s, the whole industrial scenario has changed. And we will look at it how it has changed. We will look into the industrial sentiment, changes in the industrial sentiments, as well as based on the changing sentiments of the industry, what was the expectations from the maintenance. It has changed in due course of time. Before 1950s, the world was not hugely industrialized, so the equipments were not highly mechanized. and the equipments were very simple in design, very robust in design, very huge, and they were running smoothly. So there was no much of expectations from the maintenance to do a lot of job. So they were operated till run to fail. So the maintenance job was just to fix the equipment whenever it was failing. After 1950s, when there was a huge demand of the products and less manpower, the industrialization started to do mechanization. Due to this scarcity of manpower, they started mechanization and they became aware of the equipment failure. And they also started realizing that it requires more maintenance because of more mechanization, and because of which they wanted to control the cost on maintenance. So the expectation from the industry for the maintenance, because of this change in industrial sentiment, was the higher plant availability. They expected to have the longer life of the equipment, and they wanted to control the cost and to lower the cost. Next came 1970s, where more industrialization started taking place, and from mechanization they went to automation. With more automation, the equipment designs became more complicated, and people started realizing the importance of environmental health and safety. They wanted to have zero accidents and zero incidents, zero pollution to the environment, and good health for the employees and the people. So based on this, the expectation from the maintenance also grew further. Basically, it was raising the bar step by step. So the expectations was to improve the reliability as well as the availability of the plant, better EHS performance, and longer equipment life. This is a brief history of the expectations, growing expectations from the maintenance. Let us see now how the maintenance as a field, it responded to the growing expectations. As you can see in this curve, initially it was only to fix the equipment when it is breaking down. Later, they started analyzing why is it breaking down, and let us not allow it to break down. So this was how the maintenance was responding, using initially it was reactive maintenance, then preventive, then predictive maintenance, and so on to TPM. So finally, as we all know, now we are working on reliability centered maintenance RCM. This is how the maintenance department also grew up to meet the growing demands of the industries. Now let us have a small case study. How it will be look like. See, let us just assume there is a failure of a pump in an industry, and it has to be attended. Earlier, what used to happen? When a pump has failed, a technician will be called from home, please attend this pump. As soon as the technician comes here and he starts, okay, this is the problem, he starts to understand the problem, this is just a timing, approximate timing what is given. He takes around 30 minutes to understand the problem. Then he goes and refers to the technical manuals, how to attend this problem, then arranging the tools, applying permit, waiting for the permit, obtaining the permit, dismantling the pump. After dismantling, he finds out he needs this spares, so he goes to the stores or somewhere to arrange these spares, and then he repairs and assembles the pump and closes the permit. See, if you see in this case study, it took around 735 minutes. What if the technician has a clear-cut scope available in front of him? This is what we have to do it. What if all the technical details are readily available to him, so that we don't need to waste all the time of 40 minutes what I have shown here to understand the problem? What if he has all the tools and resources and the equipment is already isolated, readily available for him to take up the job? Just consider that case. Before that, let us see what is happening in this. Here, the process of working, that first scenario, what I was telling you, it is a very zigzag manner here and there. Because, though I have shown for simplicity in this flow chart, basically to understand the problem, he may have to go to the site, he will come back and refer to the technical manual, he may have to again go back to the site to cross check, he may require some external subject matter expert support. Those things are happening, and this is how it is happening. Try to correlate what happened in the initial 20 seconds when they came here. This is the thing. That is what I wanted to show you. Since I was not aware how to use this, I was asking about it. Because it was not clear to me. I was wondering how to operate this slide. So this is how the initial process, and I am sure that you people did not like it. Okay. So this is how it is. So now let us see what if conditions what I have put here. What happens in that case? Simply when the pump is filled, he has all the required information available with him. So he directly goes, obtains the permit, opens the pump, does the necessary repair because his plans are already aligned and available at site, and he goes and closes the permit. This takes around 330 minutes. This is a simple comparative case study. Here, if you see, the process is very much streamlined. This you can see here, this is just a representation of the process what is going on. Okay. Now, let us compare these two scenarios. The scenario 1, the total time consumed was 735 minutes, whereas in scenario 2 it was 330 minutes. So the time of doing the productive work, if you remember, the productive work was only obtaining permit, disbanding the pump, repairing and closing the pump, and closing the permit, which was practically 330 minutes. So it is the same for both the cases. And now I would like to introduce you here terminology used in planning, which is range time. Range time is the actual time a person is working with the equipment of the machine. So if you see, in that case, he was taking 2 hours for disbanding the pump and 3 hours for assembling and boxing of the pump. So this is the actual time he has worked on the equipment. So this is the range time. So in both the cases it is 300 minutes. Now if you see the productivity ratio, what is the percentage of productive work he has done in scenario 1? In scenario 1 he has done a productive work of 330 minutes out of total consumed time of 735 minutes, which is for around 45%. In case of scenario 2, it is 100% productive work he has done. Also if you see the range time, in scenario 1 it was 40% and in scenario 2 it is around 90%. I am sure everyone would like to have scenario 2. Now the question arises, how can we achieve this scenario 2? We can achieve this scenario 2 as I said you earlier, that if you have all the necessary information is available to the person who is working, all spares are available, all special tools and factors what is necessary for overhauling the pump is available readily, and the equipment is already isolated, trained and kept ready for the technician to go and work on it. How can this be achieved? Next question is, how can this be achieved? What is the methodology we can follow so that we ensure that the technician gets all these things readily available with it? It is possible by planning schedule. If the job is properly planned and it is scheduled for particular timing, so that the technician when he goes, the equipment is already isolated, he has all the necessary things available with him, he can go and do the job. This is how we can achieve scenario 2. And most importantly, it is not only time scheduling, it is following the plan and schedule. That is the more important than planning and scheduling. One of my teachers in my school used to tell me one thing. It is, while you are running a 100-meter race, if you run 99 meters and you sit down, then you will never win the race. It is the last 1 meter which you have to move. You have to run and complete the race. This planning and scheduling may be 99 meters of race, but last 1 meter, which is to follow the plan and schedule, is most important in this aspect. Now let us see what is planning. As I told you earlier, I have given you a brief outlook of what planning involves. So planning involves giving a clear scope of work, giving all the necessary technical details required so that the job can be performed satisfactorily. All the necessary spares are arranged before the job. All special tools and tractors and equipments are arranged. All potential EH&S hazards are already addressed. What safety precautions he has to take, all those things are addressed already. And last but not the least is all the required resources, how many mechanical technicians, how many pipe fitters, how many electrical technicians are required, what is the duration they need to work on it, are all assigned and planned for. So, is this enough? Can maintenance planning contribute to the industry more than over and above whatever is there? Can, as you all know, the oil prices are dipping nowadays day by day, and we have to go into more productivity and cost saving and more effectiveness. Can planning contribute more to the industry for its progress? How can planning be a partner in progress of the industry? Yes, it is possible. Planning can contribute more by having advanced planning in place. What is advanced planning? Simply when a job is coming to us, it is not that blindly we go through it and assign resources, arrange tasks, everything and do the job. The planner does much more than this in advanced planning. He analyzes the past history, what is the frequency of failure of the equipment, how it failed, and what mitigation measures have been taken earlier, and what is the newly available technology to mitigate this failure so that you can extend the life of the equipment. As you can remember in the third generation when they were showing you, the expectation is to extend the equipment life and more reliability, which is the current scenario. The maintenance planning can consult subject matter experts, reliable engineers, because the person who is planning need not necessarily be a master of all these subjects. So you can consult the experts and you can provide better planning. It is not that there are some jobs which actually are required to be done at site. There are some jobs based on the decision is taken emotionally, not on practical basis. Like I like that this will look good. It will be very subjective. Many times the operations request us based on emotional desires rather than logical requirements. So the planning department can challenge the jobs so that you don't need to spend money and to get saving of the money can be achieved. As well as you can challenge technically for taking some decision. If a pump seal is failed and it is to be repaired in the same material, with the evolving technology, the planning can challenge, after consulting the subject matter experts, they can challenge this design and they can have a better design in order to extend the life. This is also possible. So, this will in turn improve the reliability of the equipment. As well as we can explore alternatives to reduce the cost. There is no one way to do any job. A job can be done in many different ways. So planning involves various choices. Finding out what are the choices available to execute some job and how to do it most economically and efficiently. Now let us see what are the broad steps involved in the plan. First and foremost is to establish the objectives. What I am going to do. Everything is objective driven. What is the needed end result and how it should be achieved. Next is to establish the planning premises. Basically, establishing planning premises involves to look into what are the alternative methods available and what is the boundary for us and how best can this job be done. Next, as I said you just now, it is to explore various alternatives and take the right decision. And to form derivative plans. Forming derivative plan involves twofold. Number one is, for doing a job, For example, let us say that a motor of a pump is failed. So basically, the motor needs overhauling. For doing the overhauling, you have to have first you have to have mechanical support to remove the motor and send to workshop for overhauling. Then the electrical people will do the overhauling. So it is not only one craft, it is all supporting craft, and you have to make various sub plans in order to achieve the main plan. This is what is derivative plans are. Plus, this is one fold I told you. The other one is derivative plan is basically one has to expect what something wrong can go, and you have to have some plan B so that the job is accomplished in a safe manner. And to secure cooperation, if planning is not good. This is a very simple example I am giving you, maybe more complicated in the industry. If planning is not there, for obtaining a permit, the unit will say that we don't have any information, we have not prepared the equipment. So we cannot give the permit, and the technician has to wait at it. Whereas, if planning is done and scheduling is done and the schedule is communicated to the concerned people, this equipment can be made ready well ahead of time so that there is no waste of time. So it is a matter of having securing the cooperation between the planning, execution team and the operations, as well as the equipment. And one of the major backbone of planning is the follow-up and appraisal of the plans. No plan can be 100% perfect. It is not simply possible to make a 100% foolproof maintenance plan. As I told you earlier, a job can be done in many different ways. A planner is a person who is well experienced to do the job, whereas though he is doing a good job, the field technician who is working, he is toiling in the field and he knows he will come across by his own experience a better ways to do the job. So the planner can take back the feedback from the technician and improve the plan for future use in order to do the job safer, economical. This is a representation of how the planner job and the product of the planning is. So the input to the system of planning is the engineering standards, engineering facts, maintenance strategies, cost estimates, procedures, job requests, equipment history, all those things. And the output is the work package. The work package ensures that in-spec parts are available for the technician at field, equipment condition is ideal for doing the maintenance job, there is least distortion, and all procedures and technical details are provided so that the job quality standard is high. And based on that, the planning takes the feedback of the knowledge, observation and learning from the field and it is improvised back in the plan. Let us quickly go through the characteristics and benefits of planning. Planning is goal-oriented. I think it is self-explanatory. It is looking ahead. Basically, the planner who sits in the office, he looks ahead while doing the job, what is going to happen. He visualizes. It has a creative thinking. So, what is going to happen, what problems the field person can face and how to mitigate it, everything is addressed in planning. It is an intellectual process. Needless to say, it is not a routine mechanical job, repetitive job. Just one has to think differently, one has to have a creative thinking and a visualization to do a good plan. It involves choice and decision. Thus, you have to explore various alternatives and to weigh the alternatives qualitatively or quantitatively and come to a conclusion which is the best way to do the job. It is a continuous process. It is never ending process. Till the industries exist, this planning has to happen. It is designed for efficiency. So whatever I have told you, already it is flexible. So we just saw that the planning takes a feedback and improvises in the planning. So it is not a very rigid that this is the plan, you have to follow like this. That is why there is a feedback loop is provided so that based on the feedback this plan can be modified, because the industrial scenario is never static. Not even the industrial scenario, coming to the lower level, what is happening today may not happen tomorrow, depending on the situations. So the plan has to be flexible, and it is flexible. It ensures smooth coordination between all the crafts and departments involved. It improves the employee morale. Like in the first case, if you saw that zigzag process, even everyone is there, he will get fed up. Once he will do, twice the person will do, but he will get fed up and it will not work properly. So once you have a smooth flow, it is clearly known that this is the requirement from me and this is how I have been told, I will do it, and so it is a tension free. So it improves the morale. It achieves economy because it involves choices and weighing the various choices and we find the best way to do a job. So it helps to achieve the economy of the job. It facilitates controlling. Controlling means what? Basically, you need to know what job is to be done, what jobs to be done today, but it is done. Ensure that it is done properly, because we have a schedule with you. So based on the schedule, we know that this has to be done, so it can be easily controlled. And it encourages innovation. So as I told you earlier, that planning involves creative thinking. It involves thinking into the future or what can be done, what else can be done. So it encourages innovative ways, and even you get a feedback from the people. That encourages the innovation of the people who are working in the field also to ensure that the job is done safely and most economical way. So let us briefly look into the contribution of planning to the industry. So as we said earlier, it may be a repeat, but I wanted to show you it contributes to improve the maintenance. As we discussed earlier, the first and second scenario, if you remember, the range time was 40% and 90%. So it improves the range time, means the time the technician is involved in the field who is doing the job actually on the equipment. So it improves means you have a better utilization of your resources. So this is the next comes the better utilization of your resources. It ensures schedule compliance. So once you have a proper planning and scheduling, so it is very clear for the person. Yes, today morning if a technician comes, he has a schedule already in his hand. He has to go to that XYZ firm and he has to go. It is very clear. So it ensures. Morning he comes, he looks around and takes things. This cannot happen. So this ensures schedule compliance and need-date compliance. Need-date compliance is maybe a terminology which is it may be new for few of you. Basically, if I am an operation unit and I have a problem in the plant, based on the criticality of the equipment, I need to know by when I can afford to run this pump or I can afford to have this breakdown in the plant for the smooth operation of the plant. So the operations gives you the requirement. Though you may find that schedule compliance and need-date compliance look similar, but they are not exactly the same. Schedule compliance is different. Need-date compliance is, as a customer from the operations, I demand from maintenance that by this date, I need this repair to be done, or this equipment to be fixed. That is schedule compliance and need-date compliance. Whereas schedule compliance is dependent on the need-date of the sonarity schedule, either well ahead of time or on the same. And environmental health and safety, yes, planning contributes a lot because while planning itself, all these things are taken into consideration. Second part is the improvement of reliability. It ensures equipment availability, equipment reliability, cost effectiveness, and monitoring the performance and improve upon it. And let us now look into the key performance indicators of maintenance. First is the time to process the work request. When a unit gives me a work request, how much time does the plan takes to process it and to convert it into an actionable work plan? Next is the overview of preventive maintenance. We have already talked in previous presentations about preventive maintenance law. So, if an equipment is to be done, the preventive maintenance on an equipment to be done on time, is it done on time or is it done late? If it is done late, it is overdue. So there is another key performance indicator. Planned versus actual maintenance. I will talk about it a little later because I have a separate slide. I have a case study on this. Next is the schedule compliance, as I have told you. Then the needed compliance. The last but not least is the manpower utilization. How planning has improved the manpower utilization. Now, let us see a case study of Kuwait. As I was telling you, the planned versus actual hours. Planned hours and the actual hour means basically in a work order, I have planned for 10 hours of job. Whereas the field technician does it in 16 hours. What is the effect of this? If the technician takes 16 hours, it means the next job is getting affected. Because from the 11th hour, some other job is planned and it is not done. Whereas, when I plan a job for 10 hours and the field technician has done it in 4 hours, it means that from 5th hour to the 10th hour, he is not scheduled for any job, he is waiting. So, this will affect either the utilization or the schedule compliance. So, this is the defect what we have defined. And in Kuwait, we have taken a Six Sigma project and we have studied it, what was the compliance in the past years. It was in the range of 40 to 45%. And we have followed the MAIC, measure, analyze, improve and control process of Six Sigma to reduce this defect. And we have identified the root causes and we have implemented various corrective actions. And the compliance has grew up to 75 to 80%. So the benefits what we have received is the schedule compliance has improved from 58% to 88%, as well as the manpower utilization has grew up from 80% to 90%. So thus in a nutshell, maintenance planning helps to improve the maintenance and to improve the reliability. It's not only planning and giving for the maintenance to streamline the job, it contributes a lot to improve the reliability and availability of the plant. I would like to end with 2 quotes. Planning. These are the quotes from some management gurus. Planning is deciding in advance what to do, how to do, and who to do it. It bridges the gap between where we are to where we want to go. And it is a